Good morning.
Good morning.
All right. So now we left off this yesterday, kind of abruptly. Computer decided it wanted to hiccup and stop working. So we were right here. So using part 2 of the fundamental theory of calculus, that means now let's go back. Okay. The second fundamental theory of calculus. Okay. What was it?
It was.
Integral minus
Yeah, so it's the top minus the bottom, right? So the integral of the top minus the integral of the bottom. That's basically it, right? Okay, all right, good. So now I would like you people right now. So since we have been doing a couple of these, I like the weird stuff. Okay, so let's start with B. Right now, I would like for you guys to do B. Okay, and so since we're looking for exact answers on this one, okay, let's see. Integration of cosine is going to give me positive sign. Okay, so it goes counterclockwise. Remember, it's the antiderivative. Is that a better way to think about it? Antiderivative. So it goes the opposite. So that means, so I'm going to have sine. So it's going to be the sine of x from 0 to pi over 6. So top minus bottom. So at pi over 6, sine is going to be 1/2, right? So it's going to be 1/2 minus the bottom. Okay, so sine at 0 is going to have no height, so that means it's going to be 0. So my answer is 1/2. There we go. You can do it. It's all up to you. Okay. Okay. Don't do drugs. All right, so I have a special candy for who could tell me what I need to use for C. Go ahead.
Wait, the antiderivative?
For that one, yeah. What would I do?
The opposite sign, the one with the negative 1.
Okay, but for which one?
Oh wait. Oh, wouldn't it be like I would guess secant?
You got to say the whole thing.
Inverse sign.
Oh!
No, is it
Tangent.
Inverse sign?
Is it?
Yeah.
I think it's tangent. Wasn't it
No,
tangent?
tangent is
That's
1
fine.
over, wait, 1 over
No,
1
the
plus
tangent
x
is supposed to be
squared.
one. Sine. No, it's not sine.
Secant.
It's either cosine or sine. It's not secant.
It's not?
No, cosine is negative.
No. So,
It is sine.
It's
Sine.
Is it sine?
Okay, now what's the word for it though?
Arcsine.
Inverse
sign.
Arc sine. There you go. Here you go.
Yeah.
Yeah, she had it. Okay, she was just trying to figure out what it is. So arc sine. So we know that the derivative of arc sine is going to give me this, right? So the derivative of arc sine gives me this. So the antiderivative gives us arc sine. So we have arc sine.
I love this.
Guys, we should all pass this test.
I know, right? You guys feeling good?
We should.
We should.
Word.
Okay.
Should.
Should. Okay, so now this is actually super important. Now, since arc sine is opposite of sine, right? So at sine, I give you a point on the x-axis, and you give me the value. Now with arc, I give you the value, and now you give me it on the x-axis. So you're gonna have like something at pi over something.
Oh.
So arc sine. So first, top minus bottom. Okay. So where? So think about mental picture. Okay, mental picture. So sine. I'm talking about sine, right?
Yeah. Yes.
Okay, sine, sine, sine. Now, where is sine going to be read 3 over 2?
By 3?
Pi over 3, right? So I'm going to have pi over 3. Okay, so I'm going to have pi over 3, right? Okay, so we're normally only dealing with first quadrant here anyway. Okay, so it could also be second quadrant because the domain for this one is actually, for arc sine, it is actually quadrant 1 and quadrant 4. It is. It's quadrant 1 and quadrant 4. So that's the domain for the inverse because of if I go quadrant 1, quadrant 2, all the sign is positive. Right? All sine is positive. Because it's above the axis, right? Sine is my y value, right? Sine is the y value. So it's all above the axis, quadrant 1 and 2. So its sine is all positive. So that's one way to think about it. And then, so that's why the domain of this one is going to start in quadrant 1 and goes to quadrant 4. So my domain for my inverse is from negative pi over 2 to positive pi over 2. So you always have to have a positive and negative if you think about it. So the domain for arc sine is from negative pi over 2 to positive pi over 2. So it's in quadrant 1 and 4. Okay? So now, on that same idea, what do you think the domain for our cosine would be?
0 to pi.
0 to pi. So that's going to be from 1 and 2 because in quadrant 1 it is positive, right? And in quadrant 2 cosine is negative, right? So there's my positive negative, right? So that helps you out with your domains for these ones right here. Okay? So yes, it could have been 2 pi over 3, but it's outside the domain of arc sine. If you guys go back to the references that I gave you guys a while ago on this, yeah, it helps you with that. So if you think about a mental image of the unit circle, you can think about it like that, in that terms. Okay, so now, mental image again, sine. Okay, where on the unit circle is sine going to be 0? At 0 pi, right? So my answer is pi thirds. Now, I like this one. This is one of my favorites. What is it? ln x, right? So, if my, on this one right here, since it's special, if my derivative gives me 1 over x, okay, if it gives me 1 over x, it has to be ln, because watch this. Watch very carefully. So if I move this to the top and I say x to negative 1, right? Every time I do an antiderivative, I do what to my exponent?
You
Add 1. Okay, so if I add 1 to my exponent, what would it give me? Wouldn't that give me x to the 0? And what do I have to do with my exponent? Divide by it. There we go. Okay? So, this one right here, even if you mess it up and you try to do it in this manner, you should have bells ringing saying, oh crap, something's wrong. If you didn't remember that it's ln, okay, I moved it up, it's negative exponent, add 1, I get 0, I divide by 0, oh crap, something is really wrong here. That's when you should actually have something in your brain kick you right behind the eye, right there, right there. Ugh. Okay, and you should know it's going to be an ln. So that's where it comes back in to remind you about that. So that's going to be an ln x, ln of x, okay, and that's going to be from 1 to 2. Why did I put an absolute value around that ln?
Can't be negative.
It can't be negative because ln does not exist in negatives, does it? Yeah. It goes down, right? Yeah. So the graph of ln looks like this. And it goes right here. It touches at 0, and it goes down like that. Or yeah, it touches at 1 right there.
Wait, which one is the one that starts here and then goes that way?
The square root.
Oh, okay.
The square root starts at 0 and goes like that. Yeah, that's the square root of x. Okay, So it doesn't exist for anything in the negative. So whenever we're evaluating, this is super important because this is one of the things that might get you on that AP exam when you do the free response. Okay? If you're just taking the integral and you're not doing anything else, you're not doing the bounds and stuff like that, okay, you have to always put absolute value on it. Otherwise it's incorrect. Okay? You have to state it with the absolute value on this. So, absolute value, because even if I'm plugging in numbers, okay, over what domain, it's got to be absolute value. Okay? All right, so now, top minus bottom. So it's going to be ln2 minus ln1. All right, and what do we know about one of those?
They have the same bases. Oh, wait.
Say it. ln1 is 0, right? I just showed it on my graph too, didn't I? Right here. So at 1, ln is 0. So ln1 is always 0. Okay? So that's going to be 0. So my answer here is ln of 2. All right, so now find the area of the graph from here to here of that. Okay, so go ahead, write out my integral. What's my integral going to be? So integral from -1 to 1. Then it's what? E to the x dx. Do not ever forget your dx. Okay, let's do antiderivative. So first, what's the derivative of e to the x? So therefore, the antiderivative of e to the x is e to the x. So I'm going to get e to the x, and that's going to give me -1 to 1, right? Top minus the bottom. So I get e to the x minus, and that's going to be e to the -1, right? What? Oh, I did, didn't I? Sorry. There we go. All right. Positive 1. There we go. All right. So we know, what do I do with the negative exponent? I put it down. So this is going to be e to the 1 over 1 minus 1 over e to the 1, right? And for them to have common denominators, by e to the 1, right? So multiply top and bottom by e to the 1. So this is going to end up becoming, so it's going to be, yes, e squared minus 1 over e to the 1. All right. Interpret the integral of a rate of change. So part 2 of the fundamental theory of calculus states that under certain conditions, if f is antiderivative f, then basically top minus bottom. All right, so f is the antiderivative, so that means that capital F, that means the antiderivative, prime, so the derivative of the integral is the function. The derivative of the integral is the function. Okay, derivative of the integral is the function. So, that means the same thing here. So, we have, basically, it's the capital F, right? So that means that's the integral. But it's the derivative of the integral, which is just the function. So, this is already, and now we are taking, so this right here all turns into just f. So we're going to take the integral of f, which is going to give me that. Does that make sense or no? Maybe? Llama? No? Okay, so right here. So you know the capital F means it is the integral, right? That's the notation for it. So we know that F prime would mean that's a derivative, right? Okay, so the notation for integral is capital. So that's my integral, right? And if I put a prime right here, that means it is the derivative of the integral. Okay, so I'm going to go back to my sine cosine wheel, okay? All right, so sine, cosine, negative sine, and negative cosine, right? Okay, so what this says is, okay, right here. So first, it's the integral, right? So I'm gonna use my wheel and go this way. So it says the integral first, right? So we know if it's the integral, it goes counterclockwise. So let's start at sine. So that's the integral, right? Okay, so that's the integral. So it went from sine to negative cosine, right? But now if I put a prime right here, that means I'm taking the derivative. So now I'm going from negative cosine back to sine, right? So now, isn't that just the function I started with? Yeah, that's what I'm doing. So all this turns into just the function I started with. Okay? Okay, there we go. All right, so that's what we're trying to get at. So in other words, the integral from a to b of the rate of change of f equals the change of f from a to b.
Okay.
All right, the population of the United States growing at a rate of p prime of t. So what does that mean? Okay, basically, yeah. So it's going to be, it is 2.867 times 1.009 raised to the t million people per year, where t is the number of years since 2015.
Wow.
Yeah? Okay, so find the integral. So now, t is my variable, right? Yeah? Okay, so if I need to try and write it out like that, that means that it is now, it's p prime of t. Yes? So my function, so let's go on another page, sorry. So read me the problem, please. So it's going to be from 0 to 5, right?
Yeah.
Yeah, and that's going to be
P prime.
2.867
Oh, 2.867 times 0.009 raised to t.
and this is there we go. Because it's in terms of time, isn't it? Yes? Okay, so let's go ahead and start by doing a couple things. Now, we have to go back a little bit on this one. So if my variable is the exponent, we've done e to the x a lot, right? E to the x. Well, what about 2 to the x? Do you remember how we did the integral of 2 to the x? Two to the x. There was a special format for that one. Yeah, we're going to have to do an ln. Okay, so a couple things I'm going to change. Okay, so there's one thing. This is one thing that we really haven't talked about very much. It's a common factor. Okay, Common factor. So it would be, in this case, like a k value. It's some constant or coefficient that's in front of my value to make it, okay, a little bit easier. So we're going to factor it out. Okay, and where I'm going to put it is going to be in front of my integral. So it's going to be 2.867 outside from 0 to 5 of 2.867 1.009 to the t dt. All right. So
You still keep it?
yeah, we're still keeping it. I'm just factoring it in front. And it makes the math a little bit easier. So we're really not getting into too much of this yet. Okay? Because this one's super ugly. It really is. So we're gonna do a bunch of LNs on this. But what I'm gonna have you guys do instead is let's put it in the calculator to see what we get.
Why can we factor out of why can't we factor? Why
You could do this all the time, but this is the first time I'm showing you how to do it. All the time. If there's a common factor in anything, then as long as it doesn't have a variable, you're not going to factor out the variable. You're going to factor out any coefficient, any common coefficient to make your integration smaller. Oh, wait. I'm sorry. I wrote that twice. Sorry. I just noticed that right now. I'm like looking at my notes. I'm like, oh, crap. Okay, sorry. Yeah, anyway. So it comes out like this. 2.867. You know what? I like red. Red works better for me. Okay, and that's going to be parentheses. I'm going to end up with the inside point, 009 t over ln of 1.009. Like that. All right, so what do we come up with here? So top minus the bottom, you guys actually did this already, right? You guys put it in the calculator yet?
Yeah, I did.
Okay, what do we come up?
Integral of it?
Yeah, the integral, right? The integral right there, right?
Yeah.
Okay, what do
14.661.
let me double check.
Yeah, I got that.
Okay, good. Now 3 decimal points always, right? Now let's go back to the word problem on this. So 14.661 is going to represent what?
It's gonna be the
The rate that
The growing
population growth, the rate of population growth.
Yep. Okay. So it's going to be the rate of the population growth. So the rate of the change of the population in millions for time t. Yep. Okay, so now I believe there is a part C on this one, right? Yes. So if the population of the United States was 320 million in 2015, what is projected population of in 2020? That's the rate of the change, though.
It's 5 years, right? So then, multiply by 1.1. I mean, multiply by 14.661.
Mm-hmm. And so we should come up with
Multiply 14.6.
it's over the time. That's the rate of change. So that's how much it's increasing over that time, right? Okay.
You got 4.6.
So what's my initial?
320 million.
320, right? So my initial is 320. And
Attention
is
staff and students, please excuse the interruption. Students, when the bell rings, report to your advisory. Again, students, report to the advisory class and teachers take attendance.
this is how
All
much is
10th and
changing
12th
over the
grade
course of this
advisory
5 years, right?
Teachers take
So
your students
that
to the
means
football
it
field.
started
9th
here,
grade
right?
Advisory teachers
And then it goes
take your
up
students to the
by
auditorium.
this value here.
Again, 10th through 12th advisory teachers
Yes.
take your students to the football field.
Right.
After taking attendance, 9th grade advisories take your
You
students to
agree?
the auditorium.
So it goes up by this amount here, right? That's the rate of change over this 5 years. So it's going up by that. So I add 14.661, which is going to give me 4.661. And what does that represent? How many people? So I'm pretty sure it's more than 334 people.
Million.
Millions of people. Millions of people. And let's see what Google has to say. So, U.S. population. Because guess what? We're in 2020 now.
327.
327.
I didn't know.
What kind of love?
Yeah, we're
No, it's 2018.
I'm happy
Yeah.
with that.
Mm-hmm.
actually, yeah.
Okay, this is right here. It is 2018.
But you said now?
I know, right?
Census? Maybe the clock.
It's just barely 2020 stuff.
Where's the clock?
Go down. Scroll down.
No, it goes all the way up.
There's a
It only
clock.
goes-
Well, population.
That's still not that much.
331
What's gonna be boring? Ready? 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 Ready?
as of right there.
They're taking a while.
Okay, so U.S. population is 329 right now as of January 31st, 2020. And guess what? Someone just got born.
Like Gary's.
Now, what do you guys notice about anything?
The world population. is
No, no, no. Look at right here.
Rates,
How is
birth
The
rate.
birth rate is
That's
higher
a
than
rate.
the death rate.
The death rate is higher than the birth. No.
Yeah,
Yes,
birth
the
rate.
death rate is higher than the birth rate.
That's good,
That's
right?
not good, but.
And then, but we get one more right here.
No, wait.
International migration.
Wait, the death rate is lower than.
So we get net gain of 1 every 26 seconds. So we get plus 1 every 26 seconds. So our population is still growing. All right, so don't forget, like, share, and subscribe. Hit that notification button, and